Welcome back. This really is the third part of this video, really. There's two videos before this. So in the previous two, we worked out the horizontal and vertical forces. And then in the last video, we did the resultant. So we worked out this 15.65. So if you need to go back and watch them. So this object here, we added up the horizontal and vertical. We got 14, we got 7. And then we use Pythagoras to find this 15.65. Okay, so the next bit, get a pen here, is to find, we'll find that angle in there. Look. So that's my little angle sign. Let's move this back a bit. So we've got to find the angle. Come on, Morgan. Let's get a pen. Here we go again. 1 of t. See, right, angle. We've got to find the angle now. From where I'm going from the horizontal. There, look. Horizontal. So I'm finding this angle here, which is also really the angle in there. If you think about it, that's just an angle sine theta, right? Apologies if I've got the Greek symbol wrong. So obviously we've got to use sine, cos, and tan because we've got an angle. So we've got to use sine. I can hear the moans. Sine, cos, and tan. SOHCAHTOA, which we have all done before, hopefully. Okay, so we're going to use sine, cos, and tan. Just a triangle. So I'll come down here and I'll rub a few things out. So I'm going to rub this here out. I leave that in there. I leave that in there. I'll rub this bit here out. I'll rub this bit out. So on our triangle now, we know that this side is 15.65 because the resultant is the hypotenuse. And then we know this side here is 14. And this side here is 7. So we can use now, get your calculator out. Mine's around somewhere. Where is my calculator here? Somewhere there. Cool. Is there one on here? I don't know. I'm using Canva. Anyway, so we're going to use SOHCAHTOA. I like sine, so we'll use sine. We've got all the angles. So we've got all the sides. We can use what you want. But I'm going to use sine of the angle equals opposite over hypotenuse. Opposite over hypotenuse. There's my angle. We're finding this angle here. So the 7 is opposite. The reason why it's opposite is because it's opposite. It's opposite the angle. And then the 14 is the adjacent because it's adjacent to the angle. It's called adjacent because it's adjacent to the angle. So we've got opposite and adjacent. This is the hypotenuse. I'm using sine, so I need to use that, don't I? But you can use any of them really. You could use cos, you could use tan. It's a good thing to use 2 to make sure you're correct. Because if my 15.65 resultant force was incorrect, then the mistake might add on, you know. So it's always good to use numbers that you're quite happy that you're correct with. Okay, but I'm quite happy with my numbers. So I'm going to use sine opposite over hypotenuse. Don't forget now, we're finding an angle. So you've got to use inverse sine. So sine minus 1 is the opposite over hypotenuse. Okay, so when you're finding an angle, you've got to do inverse sine. Okay, so my opposite is 7 and my hypotenuse is 15.65. So just make inverse sine look like you've got to do inverse sine when you're finding angles. Get another pen. So in your calculator, inverse sine, and then you want to do, probably in your calculator, it might give you a bracket like that. So do 7 divided by 15.65. That'll give you the angle. You get something like 26.6 degrees. Dink, dink. Thank you very much. Okay, so all that means is that we now know the size of this force and we know the angle and direction. So I'll just draw a line on you now so you can see what's going on. This thing, okay, I just draw a line roughly, right? It's not, this thing wants to try and go up like this now at 15.65 newtons, and the angle in here, ding, 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 the angle in here, what do we say, 26.6 degrees in there, look. So the resultant force is 15.65 at 26.6 degrees from that horizontal there, look. Okay, if you wanted to, you could work out from there if you wanted to, it's up to you. Okay, so we've got size and direction. So we know that this object wants to try and move, if it could, up like that, 15.65 at about 26, 27 degrees from the horizontal. So that's calculated the resultant force and angle using Pythagoras and a bit of trigonometry. Task number 2, same type of thing, if you remember. We worked out 20 and 10, and then we used Pythagoras to find the 22.36. So now I want to find, just like in the above example, this thing is going that way. I want to find the angle in there, look. Okay, so I might draw this triangle again. Get a different color pen, come on. So I've got a 10, not to scale, by the way. Got 20 there, look. 10 there, not to scale. And then I'll draw this resultant in red, look, see if I can get straight up. That's all right, like that, 22.36. That's from before, look. And we want to find the angle in there. So just like we did before, this is the opposite. It's opposite the angle. This is the adjacent. It's adjacent to the angle because the angle is in here now. Okay, I'm going from here and this one. Okay. If you're finding that one, it's a different problem, really, isn't it? Can if you want to. And this one is the hypotenuse. I'm going to use sine again, so I'm going to use sine of the angle. Don't forget SOHCAHTOA. Look, SOHCAHTOA. Sine of the angle is opposite over hypotenuse. And just like up in the first example, we're finding the angle, so we've got to do inverse sine. So on your calculator, you've got to do inverse sine. The opposite is 20, and the hypotenuse is 22.36. 22.6. Okay. So we're finding an angle, so do inverse sine, and then you do opposite, which is 20. Hypotenuse is 22.36. Make sure you're not in radians. If you know what a radian is, make sure your calculator is not in radians. Okay, so if you're in degrees, hopefully you are, you should get an answer inverse sine 20 over that, 63.4 degrees. So the angle in here is 63.4. And all that means is, see if I can move it on a bit. There we are. All that means is, like we did before, let's get a red one. All that means is this object, okay, wants to do, I'll draw a line. Actually, we don't really know, but we know it wants to go up like that, look, at 22.36 newtons. And the angle in there, let's say, is 63.4. So again, we've got resultant force of 22.36 using Pythagoras, and we've got direction and angle using a bit of SOHCAHTOA, 63.4. So here's number 3 that we did previously. Don't get a pen. So in the previous 2 videos, we worked out the 7 and the 8. And then we found the resultant force using Pythagoras, 10.63, coming down now, right? So now, same thing, I'm going to find the angle from the horizontal in there. I'm going to find that one and that one. So I'm finding it from this horizontal. So again, I'll draw my triangle because I love drawing triangles. There's my 7, not to scale. There's my 8. Okay, and then I'll get a red coch in Welsh. I'm trying to find the angle of that resultant force. I'm finding this one in here, look, that angle in there. So like previously, I'm going to label up my forces. I'd label them up. The 8 is the opposite, because it's opposite to the angle. The 7 is adjacent, because it's adjacent to the angle I'm working out. And the longest side is always going to be the hypotenuse. So I'm finding this angle. I'm finding this angle, this angle. It's all the same angle. So I'm going to use sine again, look. So sine of the angle, look, opposite over hypotenuse. You can use cos if you want to. You know, SOHCAHTOA, up to you. It's good to check because you get the same answer, hopefully. I'm using sine, so sine is opposite over hypotenuse. Just like in the last 2 examples, we're finding the angle, so you've got to inverse. So on your calculator, sine -1. It might give you a bracket like that on your calculator. The opposite side is 8. Hypotenuse is 10.63. Okay, so in your calculator, 8, 10.63. Make sure you're in degrees, not radians. To inverse sine 8 divided by 10.63, and you get an angle about 50. That's the angle. So I'll draw my line of action, because that's what we're trying to do, really, find the line of action. The line of action just means the line of action, which way this thing is going to go. So this one, it's coming down something like this. The resultant force is 10.63 newtons. And the angle in there somewhere, the angle from the horizontal is, what do we say? 48.8. 48.8 degrees from that horizontal there. Okay. You could find that one there if you want to. Well, that one is just 90, take away 48.8, isn't it? So again, we've got resultant force of 10.63. We know it wants to come down this way at an angle from that horizontal, 48.8. So a number 4, get a pen. What color should we have? This one. So in the last 2 videos, we worked out, we got 3 and 7 as the horizontal and vertical. This is kilonewtons now. Don't forget kilo is 10 to the 3, which is 1,000, isn't it? So don't forget that. Kilobyte, kilonewton, kilogram is 1,000. So kilonewtons, 7 kilonewtons means 7,000. So we've got 3 and 7, and the resultant force using Pythagoras was 7.61. I want to find now the angle in there. Okay, the angle in here. So I'll draw a triangle again. Not to scale. 3 going that way. 7 coming straight down, 90 degrees. And then the resultant force, 7.61 there. These are all kilonewtons, by the way, look. Kilonewtons. And we want to find the angle in there from the horizontal. So it's the same method, really. 7 is opposite. Different color. 7 is opposite. 3 is adjacent. Not that we're going to be using it. And 7.61 is hypotenuse. So again, sine of the angle. SOHCAHTOA, look. Opposite over hypotenuse. We're finding angles, so make sure you use inverse sine. The opposite is 7. Hypotenuse is 7.61, always the biggest one. Work that out. Don't be in radians and you get 76 degrees. Okay, so you can use sine all the time. If you know all the sides of the triangle, you can use sine all the time. So all that means is line of action. Line of action. Something like this. Look, I haven't got the paper size, but there we are. That's the line of action. It wants to come down like that. A bit more, perhaps, a bit more space. Anyway, it wants to come down like that, something like that, doesn't it? 7.61 kilonewtons, because it's kilo, and the angle, let's say in there somewhere, from the horizontal is 67 degrees. Come on, give me a pen. Come on, 67 degrees. So we've got size and direction. Resultant force 7.61 kilonewtons. It's an angle from that horizontal, 67 degrees. So again, we just use Pythagoras and trigonometry. So we've worked out resultant force and we've worked out angle. The next video might be on moments, because we might have a pivot point or something. Okay, but that's coming next sometime. Okay, so we've calculated resultant and angle.